everyone, welcome back. It's great to have you here today. In this video, we are going to go through 5 EMC style questions. I recommend trying these questions yourself first. You can find the link to the question in the description box. If you need to review the content before attempting these questions, this playlist might also be useful. So let's get started on the first question. In this first question, we are told that there is a statue that weighs 20 kilograms and requires 6 tins of paint to paint it. Now, if we are talking about painting something, we're talking about the area, the surface area. And there is a plan to build a similar version that weighs 1,280 kilograms. And now we are asked to work out how much paint do we need if we want to paint it. So what I would normally do is to write down all the key information so that I know what I'm being given and what I need to work out. So I have a smaller version, 20 kg, and that's 6 tins of paint. And now there is also a big version, which is 1,280 kilograms, and we need to work out how much paint we need. So from 20 to 1,280, that is multiplied by 64, which is 4 cubed. And this is our volume scale factor. Because length scale factor cubed, it gives us volume scale factor. Therefore, length scale factor is going to be 4. So area scale factor is going to be 4 squared. 16 times by 4 squared will give us 96 tins of paint. And that is our final answer. Okay, so let's move on to the next one. So now we have 2 different solid shapes. The surface area of A to the surface area of B is 3 to 4. And we are also told that the volume of B is 10 centimeter cubed. So let's write them out. We have A and B, and we know surface area is 3 to 4. And the volume for A, we don't know. That's something we need to work out. And then for B, it's 10 centimeter cubed. So we need to work out scale factor. This is similar to the previous question, but the numbers might be more difficult to deal with. Now from 3 to 4, the scale factor is 4 over 3, and that is our area scale factor. Therefore, to work out the length scale factor, we needed to square root this number, and that will give us 2 over root 3. Rationalizing it, that means getting rid of the square root in the denominator. That will give us 2 root 3 over 3. Now we need to work out the volume. That means we need to work out the volume scale factor first. To get the volume scale factor, we need to cube our length scale factor. So using power rule, we know it's 24 root 3 over 27. So in order to work out the volume of the smaller piece, we need to do 10 divided by our volume scale factor. And we can work it out. It is 270 over 24 root 3. Because the question wants us to leave our answer to 3 significance figure, therefore our final answer is 6.50. Okay, now question 3. Now we have 3 different shapes here, and they are similar, A, B, C. We are told that the surface area of A is 4 centimeters squared. The surface area of B is 25 centimeters squared. The ratio of volume B to volume C is 27 to 64. And we need to work out the ratio of height A to height C. So what I'm going to do is, again, write out the information we are given just so that it's clear. We have 3 different shapes here, A, B, C, and we are told that the surface area of A of B. So then we can work out the area scale factor from A to B, which is 25 over 4. And then that tells us the length scale factor is going to be 5 over 2. With volume, we're told that the ratio is 27 to 64. It means that the volume scale factor is 64 over 27. And we can work out the length scale factor by cube root this number, and that gives us 4 over 3. We need to work out the length scale factor from A to C in order to work out the ratio. We are not given any information about the height of A or height of B or height of C. So what we can do is we can say, okay, now let the height of A be 1. You can use 100, you can use any number, and in the end we will end up with the same answer. But by using 1, it just makes the calculation easier. You can try it using a different number and persuade yourself that it will give you the same answer. If I let the height of A be 1, because from A to B we know the length scale factor is 5 over 2. Therefore, the length of B is going to be 5 over 2. And because we know the length scale factor from B to C, which is 4 over 3, so then we can work out the height of C, which is 10 over 3. So now we know from A to C, we need to do 1 times by 10 over 3. By multiplying both number by 3, we will get 3 to 10, and that is our final answer. Okay, so now let's move on to the next question. And again, in this question, we are given 2 solid shapes. A and B, and we are told that the surface area are in ratio 4:9. And now Taylor fills shape A with water. She then pours the water from A into B, and then she repeats the process until container B is full of water. And then we want to work out the number of times that Taylor needed to fill container A. Again, I'm gonna stick with my method. I write out A and B because they are two objects, and then we know that the surface area are in the ratio 4:9. Therefore, our scale factor is gonna be 9/4. So then that tells us the length scale factor is 3/2. Therefore, we can work out our volume scale factor, which is 27/8. And again, we are not given any information about the volume of A or B. So what we can do is we can say, okay, let the volume of A be 1. And because the scale factor is 27/8, then that means the volume of B is going to be 27/8. And 27/8 is 3 and 3/8. That means Taylor needed to fill the container A 4 times in order to fill the container B. So I'm missing a sentence here. I needed to write that final conclusion down. Taylor needed to refill container A 4 times. And that is my final answer. Okay, so now moving on to the final question. Now in this question, again, we are given two shapes, prism A and prism B. Now we are given different information, so we need to be really careful when reading the question. So we are told the volume of prism A, prism B. We are also told the area of the cross section, which is a right angle triangle, and we are told the base length of the triangle in prism B. So again, a lot of information. I'm gonna set out my solution by saying, well, I have two shapes, A and B. I'm given the information about their volumes. I'm gonna write them down as well. So from here, we can work out the volume scale factor straight away, which is 27, and then that is 3 cubed. So that tells us the area scale factor and length scale factor as well. We are also told the cross-sectional area of shape B. So in order to work out the cross-sectional area of prism A, I needed to divide this number by the area scale factor, which is 3 squared, which is 9, and then that is 4.86. We are also told the length of prism B, which is 8.1, and then the length scale factor is 3, therefore I'm dividing this number by 3, and that gives us the length of prism A, which is 2.7. But in the question, we are asked to work out the height of this right angle triangle. We know that the area of a right angle triangle is a half times base times height. We know what is the base, we know what is the area, we just needed to rearrange to solve the equation to find out that the height is 3.6.
That is it for today. Well done for making through to the end, especially if you have done the questions yourself. Remember, maths isn't a spectator sport. You have to keep practicing to be more fluent. Happy revising, and I'll see you in the next video.